Hello, Coach Travis here with another calculus video. So this is a video about the net change theorem. So we'll see how the net change theorem gets used in just a minute. But let's look at the question first. So the idea is we got some function, capital F of x, and they tell us that capital F of 0 is negative 2. And then they say they give us the derivative of f, they give us the graph of the derivative, f prime, and they want to know what is f of 1. Okay, so let's be clear on what our goal is. Our goal is to figure out what the value of f of 1 is. And so this is one of those dirty problems where they kind of try to trick you, or it's easy to get tricked. That you might be tempted to say, oh, well, this should be equal to 4. Because look, when I put 1, when x is equal to 1, then the function is equal to 4. So you might be tempted to say the answer's 4, but that would be wrong, because I want to emphasize this graph is not the graph of f. This graph is the graph of f prime. Right? It says the graph of f prime. So this is one of those dirty problems where they ask you a question about a function and then they give you a graph, but the graph is not the graph of the function you're actually interested in. And so that's kind of what makes this problem fun and interesting, is they're asking us a question about a function that we don't have the graph of. The only thing we know about capital F is, well, I guess we know two things. We know that the value of f of 0 is negative 2, and we also know the graph of the derivative function. We know that the graph that we are given is not the graph of capital F, but it's related to the graph of capital F because it's the derivative. So somehow we have to put these pieces together to get to our goal of finding f of 1. All right, so the secret here, the secret weapon here is going to be to use this net change theorem. Because essentially what the net change theorem does for us is it says, hey, if you know something about the derivative, because in this statement of the net change theorem, the lowercase f is the derivative. So if you know the derivative, then you can use the integral to find out something about the original function. So that's what the net change theorem is saying here. And essentially, I mean, you might look at this and say, hey, isn't that kind of the fundamental theorem of calculus part 2? And it's true that this is basically just another way to think about the fundamental theorem of calculus part 2. So if you know something about the derivative, if you can find the integral of the derivative, then you know something about the original function. So that's going to be good for us, because that's the situation we're in, is we know a lot about the derivative. We know the graph of the derivative. And in fact, if we thought about it, we could probably even find a formula for the derivative. But that's probably not the right way to do this. So we won't do it that way. But we know the graph of the derivative, and so let's see how we can use it. Okay, so the idea here is don't think about what you should do. Just think about what you can do. So a mistake that a lot of students make is they see a problem, they see a hard problem like this, and they think, what am I supposed to do? But that's probably the wrong thing to think, because in life we encounter problems all the time that we've never seen before. We're not supposed to know what to do. But what we then get to do is we get to be creative. We get to think, well, I don't know what I'm supposed to do. I've never seen this problem before. But, well, what can I do? What are the things in my toolbox that I can use? So that's going to be my approach to this problem. So well, here's one thing I can do. I can write down the net change theorem. So I basically just repeated the net change theorem here only instead of writing lowercase f, I wrote f prime because that's the notation that's being used in this problem. So this is the plain old net change theorem. Just instead of using lowercase letters to represent the derivative, I used the prime notation. And then I look at this and I say, okay, well, this is just a bunch of letters, and this doesn't seem that useful. So if I look back to my original problem, I see that, hey, I know something about when f is when you put 0 into f. So, and I want to know what happens when you put 1 into f. So I think what I want to do here is I'm going to change these a's and b's to 0s and 1s. So let's give that a try. So this will be a 0, and that'll be a 1, and then that means that turns into a 1, and that turns into a 0. Okay, so this is just using the net change theorem. And then I now say, well, what can I do now? Well, what I can do now is I can say, well, the problem tells me that this is a -2. And let's see, does the problem tell me what this is? And it doesn't. In fact, that's our goal. So I don't know what that is, but that's probably okay that I don't know what that is right now, because that's my ultimate goal. And now, what about this integral? Can I figure out what this integral is? And if I think about it, yeah, well, what is a definite integral? Whenever you see a definite integral, what you should think is, you should think it's the area under the curve. And then, so now I think, okay, do I know the curve? Do I have the curve? Do I have the graph of f prime? And the answer is, yeah, I sure do. This picture is of f prime. So the moral is that this definite integral is just going to be the area under that curve between 0 and 1. So I'll go ahead and shade it a little bit. So that definite integral is just that, the area of that red triangle. And great, so that's just a triangle, and so I can figure out that area is going to be, let's see, the base is 1 and the height is 4, so that area is 2. All right, so okay, so I think we're in the home stretch here. I have this equation, and I think I can solve this for f of 1. So the moral here now is, if we just do some easy algebra here, we can see that capital F of no, I didn't say negative, I meant to say positive 1. Capital F of positive 1. Okay, so what do I have to do? I gotta be careful here because it's a double negative. It's a minus 2. So I need to, a minus 2 makes a positive 2, so I have to subtract 2 from both sides. So I actually get 0. So the final answer is 0. And if you think about this, it should make sense, because what is, let's think about it another way. So again, the final answer is 0, and here it is all algebraically. But just I want to just wrap up by thinking of, see if we could have figured this answer out another way. So the net change, what the net change theorem says is, it says the net change in the function is the area under the derivative. So if I look at this, I see that the area under the derivative is 2. So that must mean that the net change of the function from f of 0 to f of 1 is 2. And so, all right, so the function started at -2, And so if it needs to change by 2, well, if you start at -2, if you change by 2 in the positive direction, you change by a +2, then you're going to wind up at 0. So if that made sense, awesome. If it didn't, you can just focus on the algebra because the algebra makes it as clear as anything else.